Hi guys, welcome to Learn Electronics Repair. I have a mixer here, Yamaha Programmable Mixer 01. I'm not sure what the problem is with this, to be quite honest, so let's just power it up first and see if it actually does power up, and then from there maybe we can see we put some audio in and see if we get any audio out. That's probably a good start. So, well, it lights up. Oh! What? Oscillator, insane things. I never expected to do that. Battery check. Memory bit. I see. So this is a bit of a, well, yeah, different, I guess. I've not seen something like this before. Battery is okay. Okay, so these buttons obviously work. What was going on with all these sliders? Looks like, I'm guessing it's going to do the same thing, like you can sort of program it to switch on a certain way. Whoa! Well, I like it. I like it. So, first of all, I think we have to figure out what's actually wrong with this. So, I'll feed audio in, some music or something, and let's see if anything comes out of it. This is fun, this thing, isn't it? Let's go again. Hey, but you notice not all of these actually work properly, okay? So I have some audio connected into this. And you can actually hear that, but you'll notice that only if one of the channels has any audio on here, okay? I can swap the audio signal coming in. In fact, I'll just use the one. So that one has audio. Go to this one. Just a hissing noise. And the hissing is on the channel that I now have nothing connected to, basically. So I only have one channel working, and these sliders don't seem to operate properly. I'm not sure how these work. I'd be interested to see, actually. But I'll just get in touch and find out from the customer what actually he wants me to fix on this. Okay, so he says what I found, that he only has one channel output. I don't think he's too concerned about some of these sliders that kind of like the motorized thing doesn't seem to work very well on them. We just try that again by putting them all in the middle, and mostly because I like it. Yeah. There's another good reason, just because I actually like this, so I'll switch it off and switch it on again. Yeah. It reminds me of something, I can't just think what it was, like probably some Jerry Anderson thing, like Captain Scarlet or something, with cars that drove themselves and the steering wheel would move by itself, and the gear stick would move by itself, something like that. Anyway, so the customer confirmed the same fault I'm finding, so let's just open this up and let's see if we can figure out why we only have one channel working. I have the top off this. Now the owner also tells me two things. So he says that the only one channel output working is the same if he uses various different inputs. So I'm into the stereo input. We've got 16 channels here, balanced and unbalanced, okay? So he says that, but he also says that quite a few of the channels don't work at all. So what he's asking me is to give him a quotation on repairing this. There's a difficulty with this, and something that also makes it easier. So I have a planned method. The problem is the difficulty that this is the top board, and these three ribbons attach one here and two here. They have like a little clip that lifts up to release them, but they're very short, so it makes it very difficult to work on this when it's powered up. I could, I guess, effectively unscrew these PCBs from here and then somehow balance them across here and plug them in. I'm not sure if it will work without this attached, because you have to press some buttons on here to set which output, for example, or which input you want to be enabled. So that's the difficult part. If I was repairing a lot of these, I'd probably make a rig to do it, you know, but I could, I guess, unscrew those boards and put like a piece of wood across here or something, so I can just bounce them on there and connect them up. I think that's probably the way to do it. The good side of this, I managed to find the service manual and the schematic. Here we have the service manual. I found this on Electrotania. I've put the name on screen there for you. I actually just searched for the model Yamaha Pro Mix 01 service manual. Yeah. Actually, no, I searched for schematic and it found this. This is in a mixture of Chinese and English. I've learned a couple of things just from glancing through already. So this actually has a calibration mode. If the sliders are not all working properly, it says after it's been stored or moved, you run this calibration. It works out the torque that's required for each slider. So that's probably why they're not all moving correctly. I'll just scroll down fast and we'll find the actual schematics. This is quite nice because it shows us the layout at least that we have. So we have the top board, which is the LCD unit. I'm showing you that with the ribbon cables attached. We have the analog board. This is all your inputs, the CPU board. And then under here, there are some more PCBs. So this is the power supply, ADA. This is the output side of it, okay? And the DSP. So those are underneath here. Then we get some block diagrams, disassembly. Well, I figured that out myself actually, but perhaps I should have read it first, okay? In fact, this shows you how to get further into it, so that's quite nice. It gives us a lot of information about how the control works, all the bits and bytes that enable and disable various things. Quite nicely, the pinouts for the ICs that are used inside here. Layouts. Parts list. So everything's in here, to be quite honest. Okay, so here is the schematic now. So the first thing we can see, we have a lot of repetition in the circuit, which is exactly what you'd expect in a mixer. So these are all your various inputs. Like we have channel 15, channel 16, 14 and 13 and so on. Right back down to channel 1, channel 2. And the channel I'm actually using to test, which was the stereo input. That's this one, STN, left and right, okay. So this is where I'm feeding the signal in, but the guy who owns this tells me some of the other channels don't work either, okay, and we only get left coming out. So that tells me really that the problem, we only have the left channel working, is further down in the circuitry, because some of these inputs work and still only give a left output, okay. We can also see quite clearly we have an op-amp on the input, and then we have an analog to digital converter, a decimation filter, that decimates things, I guess. And then that effectively then gives us a digital signal which goes into the DSP board. DSP here, okay? You can see that's coming from here. Various outputs on here, serial data, yeah, serial data. So we could test this circuitry fairly easily. I could quite easily send my signal in and see whether or not I'm actually getting any input onto the ADC. But considering that the problem occurs on all of the working channels, I don't think that's anything to do with the problem. Otherwise, it would only affect one input, okay? So I think it's fairly reasonable at this point to assume that the input circuitry is okay, and there's some problem on the output side of this, because that's common to all the inputs, okay? And this is the output side of it. So we have auxiliary, send 3, send 4, headphones, monitor out, okay. I could actually try the headphones. That would have been a worthwhile test, actually, see if I get any audio on the headphones, both channels. And we have this, stereo out. So, again, we have the digital filter, digital to analog converter, and then we have a few op amps, which are probably all in the same chip. 555, yeah, those two look like a dual op amp, and this might be another dual op amp, so there's probably 2 dual op amps, and that drives the output, okay? So a good way to test this also would be to inject a signal in here or here and see if we get an output. Yeah. If we get an output, we can say this op amp circuitry is okay. Problem could be with one of these digital to analog converters, for example. If the problem isn't with one of these, it's somewhere back in the digital, the controller board on this. Now, it does say in the manual that this has some like error codes it will generate on the display, and I'm not getting any error codes, which makes me think more likely I have a problem over here somewhere. Let's see where the headphones attached to this. So they are here, phones left, phones right. Where does that come from? I can see, looking at the IC numbers on the silk screen, that all of these op amps are on this top PCB, the one we can see, okay? I've also found this connector. So this is where the headphones go. That's a 9-pin connector. Now, these ICs I can't see on the top board, but the actual outputs seem to be lower down in the mixer, so these must actually all be on the PCB that's below the one I can see. I have a 9-pin connector, which is for the volume control for the headphones and the monitor. That I'm pretty sure is this one, because these are the volume controls. These are all the various ICs we could see on the inputs, 16 channels, plus the ones for the stereo in. It's up there actually. So I can see all those. So I need to get down to the board underneath here to get further into the circuitry. So what I'm going to do is first, I'm actually going to just connect the top panel back on and see if the headphone socket works. That'll give us a good indication. So you can see down here that the headphone output is here. These are the main outputs that I'm using. This is the aux send. So we can see all these various outputs. Let's see if any of those actually work. Well guys, it's after the weekend now, and I had a few thoughts about this over the weekend, even though I wasn't working. So the first thing that occurred to me after I'd finished recording on Friday, I said I was going to get the headphones. But then I thought, well, the VU meter on here is only working on one side. And that VU meter, I'll show you on the schematic in a minute, but that's connected effectively to the CPU in here via a parallel interface. So the CPU thinks it's got no input on that channel. So I thought, well, in that case then, the fault must be somewhere on the input, but also the owner says some of these channels are not working. So I brought the headphones in, and I've found something really interesting that I think will help us to complete the quotation on this and probably give us a good idea of what we need to do to repair it. So all these buttons here, if I'll take these off you might hear them, all these buttons here select the channels that go to the output, and these rows, these select what comes to the headphones. So I have a cable plugged in here to channel 16, and if I start some music playing from YouTube, of course. Okay, and you can see I won't put the music up because of copyright reasons, but you can see that both channels actually work now. This is a mono input. I also found that the headphones give audio on both phones, and they do so even on the stereo input. So I thought, well, that's interesting. But what I then discovered is if I feed an audio signal into this input, I get both speakers on here, although this is the stereo input. So this channel feeding in actually doesn't give me any audio on here or on the speakers or on the VU meter. So there's definitely a problem with that input channel. It seems the headphones effectively are mono, regardless of whether you're actually using the stereo input, okay? So we have adverts on now, that's fair enough. So you can see that works. Now if we go to channel 15, same thing, yeah? The other thing I've noticed is that the headphones, the volume is independent from these sliders. So on a channel that's working, if I press select on 15, I can now hear the headphones. You can't hear them, they're just too quiet for you guys, I think. But it's regardless of what the slider's doing, I still actually get an output on the headphones. This becomes important if I go to channel 14, for example. So we go to 14. Now you'll see this channel doesn't work at all, yeah? But it also doesn't work on the headphones at all. So that tells me that the slider itself can't be causing the problem. It wouldn't affect the headphones. We know that from a working channel. And if I go all the way down all the other channels here, down to 8, none of those are actually working. So it's only 16 and 15 and one channel stereo and that actually works. I didn't test 7 down to 1 just because I don't happen to have the cable handy. Those are the balanced inputs. But we know there's a problem here. And we know the problem is on the input end. Now let's go back to the schematic and see if we come up with some sensible ideas of what may be wrong with this and how we should quote for this job. So what do we have and what have we proven here? Well, we've proven that all this output side actually works, certainly on channels 15 and 16, which are these channels here. So we know all the digital processing works. We know the sliders on the mixer are not responsible for the volume on the headphones. And on the channels that are not working, I get both no audio on the output and no audio on the headphones, which suggests the problem is not the slider, okay? And that's for all 6 channels I've found so far that don't work at all. So what we're down to really is all this input circuitry. Now we were looking at this earlier in the video. You'll see this is the stereo in. So this has 1 channel working. This, although it's mono, actually has channel 16, channel 15, but they both work, okay? And we're using both inputs on this ADC. It's just the mixer treats the mono signal as being on both channels. So it's mono, but it's not on one speaker. It's mono through the 2 speakers, okay? The same audio on each speaker, which makes sense for a mixer. These ones here, all these ones don't appear to work at all down as far as number 9. Okay, just 15 and 16, just that one. So these here are actually not exactly the inputs. These come on a ribbon cable from another board. Let me show you here. So these are the inputs from 1 to 8, which I didn't actually bother to test. Okay, and then these are the inputs from 9 upwards on the jacks, yeah? And we can see that they're basically the same regardless of the inputs, yeah? And we have some op amps, a couple of transistors on each one, we have op amps on each one, and then this signal, that's what goes to the input of this board here, and that's what's processed again through an op amp and an ADC. So how would I quote this? Because that's what I'm being asked to do. I could go further down into this, and actually will, because there's one scenario that's possible. But I'm not going to go further into the diagnosis without getting an okay from the customer. The one thing that could be wrong that we should check is a problem with this ribbon cable. I can see it's attached on the top board. If it's loose on the bottom board or just not seated in the socket properly, that may explain why all these channels are not working, especially because the ones at this end appear to work the first 3 or 4, then after that they don't work. Okay, so we can check for a ribbon cable, and it could be as simple as that. If it's not the ribbon cable, then we need to make 2 quotations really. One is that there's a problem somewhere on the input circuitry here. Can we fix that? Yes, it's op amps. Can we get the op amps? I'll check, but I would say yes. The transistors I'm sure we can get. So I could say, well, how many have I got? How much to repair one channel? You know, cost of parts. Multiply that by how many we've got, they're in pairs. And then I can say to the guy, well, it'll cost you this much. As a quotation. It may be less, but at least as much as this. The other one is that we've got problems with the ADC and or the decimation filter. Now, the data sheet we saw, these 2 chips work together. Okay, so if I'm going to replace them, I'm going to replace them as a pair. Can I get them? Yes. We can check to see how much it costs to replace this pair on a non-working channel. Again, multiply that by how many non-working channels we have, and that should be a maximum cost of parts if that's the problem. If it's something else like a common fault with a capacitor somewhere in here, that shouldn't be too difficult. But I wouldn't want to go down that part of the repair until the guy has agreed to both quotations. Yeah. Otherwise, I'll say, well, I can't fix it, because if I get in there and by the time I've spent the time I found it is the ADCs and you didn't agree to that quotation as one of the 2 likely outcomes, then I'm just not getting paid, yeah? So that's what I've come to, but let's have a look to see if this ribbon cable is causing all the problems. Oh, I did mention, I said I would show you where the VU meters are connected, the LEDs. So they actually connect here. We have some transistor arrays driving the LEDs. The LEDs are actually all here. We can see stereo left, stereo right. We can see where they go to. They come to here. Okay. And they are driven by this chip. This is a serial to parallel, or rather a parallel I/O. It's not serial to parallel. It's connected direct to the data bus. You can see from the CPU and a couple of address lines. So this is mapped in the address space of the CPU, and it can write to this just like writing to RAM, yeah, or any other sort of register. So that's how that's controlled, and that comes straight from the CPU. So we know when this is not working on one side or both sides, the CPU thinks it hasn't got a signal on one side or the other side. But the fact it works on some channels can really tell us that all this stuff is actually okay. I can't think of any scenario where there would be a fault in this lot that would cause these symptoms. The sliders, by the way, well, they're all here. Yeah, you can see they're all again connected onto a data bus. So you've just got 2 voltages, I would say. I haven't checked them. I need to get the board off. We've got a data bus, and that data bus goes up well into this chip. By looks like this sub CPU. Yeah, it looks like this actually controls all the motors, and then this will go to the main CPU. So again, if we had a faulty slider or more than one, from what I've seen on the working channels, the headphones would still work. And I haven't found a single channel that I tested, which is half of them, where the main output doesn't work. The VU meters don't work, but the headphones do. So I think we can pretty much write off that possibility. We could be unlucky. So this is the ribbon that comes from the main board. I have actually tried reseating this, and I know it's seated properly. It's possible that this is loose at the other end. I think you can pretty much see that all the channels come down this cable, and we can see that on the schematic anyway. So we'll have to take this board out, and then we can have a look. Okay, so we have this connector. these just lift up and pull out. They're not very good, these sort of connectors, but that's how they work. Same with this one. Okay. Of course, nothing is easy, yeah, of course. Oh, it's not so difficult. I can actually see the connector here. Yeah, and that works absolutely fine. I thought maybe it was dislodged, but it's not. It's clearly inserted. Yeah, in fact, this kind of keeps it in place. That's bent there, actually, purposely. So it's not that. So let's have a look to see how much theoretically this would actually cost in parts, and then I can work out what to quote on this one. Well, I had a look at the price for these components. So these are the ADC converters. There's one per every 2 channels. So there's actually 8 of them in total. No, actually, I tell a lie, there's 9 because we have the stereo channel as well as the 16 channels. I did this for 8 channels. So this is the price. That's for 10 of these and for 8 of these. So we could add an extra one on if we wanted. You can see the price per pair. We'd have to add 2 more. These transistors, there's 2 per channel, so 32 of those. I can get a pack of 50 for €5.55. These op amps, there's 1 per channel. Actually, I've put 16. I probably need 17. I wasn't counting the extra channel. And these are quite cheap, so there's 16 of these. In fact, this doesn't exist on the other stereo channel. That goes straight through this stage. So we can get 20 of those for $2.60. They're quite cheap. So we've got a few spare parts, but that's kind of if everything is faulty. That's the cost of parts. With regard to quotation for labour, I have a work strategy here, which I think you'll agree with. So we know where the inputs are on the schematic. And we know that we have a ribbon cable here. And also here, this is all part of the same ribbon cable that feeds the inputs from one board at the top of the mixer to the one at the bottom of the mixer. So assuming the customer agrees with the quotations, what I would do next is to feed signals into the various inputs and check on the pin of the ribbon cable to see whether the signal is getting that far. Okay. That would give me a good indication of whether the fault are on the top board or the bottom board, or a mixture for that matter. But I'm kind of working on the assumption that it's probably the same sort of problem on each channel. Here's the other side of the ribbon cable. We can see it here. So we know the pin numbers. I can actually disconnect the ribbons. I can just put my scope probe into the socket, because all I really want to do is test this circuitry on these 2 pages. Okay, so once we've done that, assuming the fault is on the lower board, which it may be, then I think I can take the top board off this mixer. So we literally, as long as we have this board powered up, I can then go down to the bottom board, inject a signal into each of these pins on the other end of the ribbon cable, and check whether that is getting as far as the ADC with the scope. In fact, I may be able to see some change on the data coming out of the ADC into this decimation filter. The 2 are just connected together. That one then goes to the buzz. So I may be able to see something there as well and get some idea of where the problem is. But I should be able to work on it like that, so that shouldn't be too difficult. I don't think it would take too long to figure out which set of chips I need to order. I probably don't need all of the parts that I effectively created a quotation for. That was a kind of a worst case, I think. So I hope you enjoyed that video. I mean, although it's not a repair, this was asked as a quotation, but now we have a good idea of what the fault is likely to be, or rather where the faults are likely to be. we've got a good strategy to work further on this, and from that I can get a good idea of the amount of work that would be involved. I was very worried about working on this lower board, then I realised effectively just use the inputs off the ribbon cable. I can just work on this on its own. We've proven basically that the fault isn't any further in than that because of the way it's behaving with the working channel and the partially working channel. Okay, so as I say, hope you enjoyed that. I think we've all learned something maybe on this one. You should have a better idea now how to actually quote for this sort of work. And I look forward to seeing you all soon. Maybe we'll see this one again, maybe we won't, depending on what the customer says. But I'm sure we will all meet again soon on Learning Electronics Repair. Ciao for now, guys.